Hello guys, I'm Alukosha Enoch and welcome to my tutorial class on numbers and system. In this tutorial section, I'll be working on IGCSE, GCSE, IB, PSAT and AISL exam style question. But this question could be quite demanding for us to complete now. So I need to take you through board work on numbers and system. Okay, so let's get started with numbers and system. So slideshow. I don't want to use time rehearsing. Okay, from the beginning. Okay, guys. So now the content to be considering under numbers and system are we taking a look at the decimal number system. We're taking a look at terminating and recurring decimals. We're taking a look at changing decimal to fraction, and then differences between rational and irrational numbers. And the decimal number system. The decimal number system uses column to represent numbers. So in this system, each column to the left hand side is 10 times bigger than the previous one. So as you can see, we have units. This is 1, 2, 3, 4, 5, 6. This is 6 units. Okay. And if you look at the number of cube here, there are 10 in each bar. Okay, so and 1, 2, 3, 4. So this is 4 times 10, so this will be 40 tens. Okay, so 40. And if you look at this board here, is 10 by 10. So each board is 100. So 1, 2, 3, 3 times 100, that is 300. So this is 300, this is 40, and this is 6. So this is 346 if you are to sum it. Okay, so what number is represented here? So the number represented here is 300. Okay, 40 tens and 6 units, that is 346. So a decagon is a 10-sided shape, or can I say 10-sided polygon? Okay, so a decade is a period of 10 years, and a decathlon is sporting event with 10 activities. So the word deck there part, the deck part of word shows it has to do with number 10. Okay, and the columns in the decimal system increase in powers of 10. Okay, so what number is represented here? Okay, now if you look at this, now this you start from the unit. This is 6 units, 0 tens, 400, 7,000 and 5, 10,000. So to represent fraction of a number, we extend the column heading in the other direction by dividing by 10. So what number is represented here? Okay guys, so we have this is 4 tens. Okay, and this is 8 units, so this is 48.03. So do not forget the decimal point when reading your number, guys. So you have 0 tens. Okay, tens is same thing as over 100. Okay, sorry, over 10, better still. This is 3 over 100, so that is 300. That's why you have to HS there, and this is 5,000. Okay, so the decimal point plays a very important role in decimal numbers. The role is to separate the number as from the parts that are less than one whole number. So in what way are these numbers different? So guys, if you look at this very well, this is we have decimal here. So this is 278.95. So if you want to rewrite this second one like this first one, you're going to have 27895 divided by 100, because this the last digit here is in hundredths position, place value. Okay, so now let's take a look at, so let's practice some activities here. Now the question here is drag the numbers to the correct column. Okay, so guys, I'm going to complete this first one here and this 3. And if you look at 3, the place value of 3 here is tens. So because this is 6 units, this is 3 tens, and this is 100. This is tenths, this is hundredths, and this is thousand. So this 3 should come under 100. So then this 6 is units. Okay, this 6 is units, sorry about that. And this 6 here is unit. This is tens, so this is tens. Okay, 0 here now. Guys, I have 0 here, and this position is tenths, th. Okay, and this 3 here, I want to complete the tax here first. Okay, so I don't have any 3 here again, because I have filled the position of 3 here. So definitely I can start with this one. So this will be 3 units. And this 7 here is position of hundredths. The place value is 100. Okay, so 1. So I can finish up this one here now, because 1 this is unit, this is tenth, and this is 100 here. So 1. So this is 136, as you can see. Okay, so 8, position of hundreds, place value. Okay, then 8 here is this is unit, this is tens. So you can bring this one here, 8. So this 6 here is in position of what? Tens, th. Okay, this 0, guys, I have a 0 here, and this is unit, tens, and this is 100 here. So you can place this one here. So 1 is thousand here, 0 here. Guys, I don't have any 0 to fill here, definitely. So, and 0 after after decimal is not significant, so it's insignificant, so I can put this 0 here just to pad it. Okay, and 7 here, this is unit, this is tenth, this is 100, this is thousand. Okay, guys, I'm through with the task now. Let's just check what we have in here. Check. Correct, guys. So guys, let's go ahead with the next task. So I will just press forward arrow. So when reading numbers, being able to break them down into chunks of information can make them easier to understand. And I think I explained this already because I have a lot of tasks to complete, guys. So what I'm going to do is that I'm going to upload this board work on my channel, so you guys will have access to it. So but let's just quickly explain this one. The first thing is that you have to take note of this decimal part. So to the left hand side of decimal, we have a number less than 1, and to the right hand side of the decimal point, we have number greater than 1. Okay, so and this is tenths, hundredths, thousandths, and this is unit, tenth, hundred. Okay, so let's just continue. This number can be broken down into 200 because this is 200, then plus 40, okay, then plus 3, then plus this is 5 over 100. Tenth means over 100, 100 means over 100, and 1000 means over 1000. So that's what we have. 5 over 10, 7 over 100, and finally, so that is how to break it down. Okay, guys, I don't know if I should complete this. Let's just quickly do this. I'll know how to manage my time. Okay, so can you match the number with the broken down units that are together to make an equivalent equivalent number here? Okay, so guys, let me just start with this one here. Let's just quickly read this one. This is 46 units. So you can see that I can match this one to this 40, and this is 6 units. I can match this one to this. This is 8 over 10. So you can take this one now here, and this is 5 out of 100. So that's that. Then if you come here now, this is 70. Okay, so when you take this 7, every other number after goes to 0. So take 7. This is 2. Okay, this is after the decimal, this is the first digit, so this is 9 over 10, and this is 7 over 100. Okay. Okay, I was just clicking without. Okay, I'm sorry about that. Okay, let me just quickly do that again. I think I clicked 7 and 2 already, and 9 over 10. Yeah, so just click this. That's all. Okay, so now this one, this is 30. Let me just be fast. I think you guys understand already. So 30 will come here, then 5 here, then 7 over 10. Okay, 7 over 10 come here too, and then finally 9 over 100. So I don't have to do this again automatically. This will just go for this, and that will be that's answer. Okay, well done, guys. So let's just continue with our task. So now this time around, we want to learn about terminating and recurring decimal. So a terminating decimal is a decimal that has a fixed number of digits after the decimal point. So for example, 0.685, 0.85, and 3.536. So terminating decimal can be written as vulgar fraction by writing them over the appropriate and power of 10. So once this has been done, the fraction should be cancelled down to its simplest form if possible. So for example, you have 85 now, so the last digit here is the place value here is 100, so automatically you should have 8 over 85, rather 85 over 100. So you now reduce this one to lowest term by dividing by 5, so 17 over 20, and that's that. You want to take a look at that again. Let me just quickly go ahead. So now this question says that can you express 0.65 as vulgar fraction? Definitely, if you look at this one, the last the place value of 5 here is 100, so you should have 65 out of 100. Now, but we want to reduce it to simplest form, so you can take your calculator now and do the and complete the task accordingly, because I'm not going to waste much time with this. So I'll just use my calculator to do the same. 65 divided by 100 will help you reduce to lowest term, and that is 13 over 20. and that is a good one. So let's take a look at the next question. So the place value of the last digit here 2, the place value here is 100, so automatically should have 52 out of 100 too. But I need to reduce to lowest term again. So if you reduce to lowest term now, I will use calculator to complete that too. Okay, I think I just want to do that, not to waste my time. Okay, so guys, so just go ahead, that will be 13 out of 25. So the answer is here. So that's a good one. Let's go ahead with the next question. So can you reduce this one? The place value of 8 here, guys, you go for the place value of the last digits. So the place value of 8 here is what? 1000. This is tenths, 100,000. So automatically you should have 328 over 1000. So I should have clicked this one, but since I need to reduce it to lowest term, I'm sorry about that, I just made a mistake. I should have clicked this one, so I'm supposed to reduce to lowest term. So you are going to have 328 divided by 1000. So your calculator will help you to reduce to lowest term, and that is 41 out of 125. So this is the correct answer here. So let's go to the next question. Okay guys, I'm not going to waste much time here because I have a lot to complete. So you can go ahead. I'm going to upload this board work on my stuff there, test shop. Then you can access it and complete the task. So let's just go ahead with the next step. Now a recurring decimal has no endpoint. It has a sequence of digits after the decimal point that continue indefinitely. So let's take a look at this. Can you convert 8 out of 11 into a decimal using, so we are asked to use our calculator, guys. So go ahead and do that. 8 divided by 11, I'm using my calculator, and my answer here is 0.7272727. So what we have here is 27 repeats indefinitely, and this one calculator just help you to round up. Okay, so however this decimal has been rounded to 8 decimal places by the calculator, so the digits 2 and 7 actually repeat indefinitely, and this is an example of recurring decimal. Okay, now so we show this by writing dot above the 7 and 2. So this dot is known as umlaut, so just place umlaut there. So in order to identify recurring decimal, we place dot above the digit that repeats. So for example, if you use your calculator, 4 divided by 9 will give you 0.444444. So because I can't keep writing 444, so you use umlaut to show that 4 repeats. So this decimal is made up of an infinite number of repeating 4s, and the second one, this decimal starts with an 8 and it follows by an infinite number of repeating 3 3s. Okay, and similarly here 2857114 indefinitely, okay, repeat, and the same here 090909. So that's what we have there. Okay, now here we have to match the fraction with our recurring decimal fraction. Guys, you have to use calculator to complete this. Just go ahead and press 1 out of 7. So because of our time, I'm going to check. Okay, so use calculator 1 out of 7, we give you this answer, and so on and so forth. Okay, so we're going to learn how to convert fraction to equivalent decimal fraction, and that is a big deal, guys, a big deal. Okay, so now can you place the item in the correct column? Okay, now to place the categories here. What are the categories we have? We have terminating, then the second category is recurring. Then to specify if give a particular fraction is a terminating decimal fraction or is a recurring decimal fraction. So at this time around, I need to go with my calculator. So I have a particular idea. I know that if the denominator of a given fraction has a prime factor of 2 and 5, then it is non-recurring, that is, it is terminating. But if 3 were to be the prime factor, then it is terminating. So I'm going to use that concept to solve without using calculator. Guys, I'm going to teach you that concept with time, and we're going to see that. But now let me quickly call your attention to that. Now if you want to know if a particular given fraction is terminating, or better still recurring, just go for the denominator. The denominator here, what are the prime factors? The prime factor here is 2, just 2. Okay, but in any case, if the prime factor were to be 3, then it's going to give you recurring. But if the prime factor were to be 2, either 2 or 5, then it will be terminating. So definitely this is terminating because it is 8, so the prime factor here is 2. Okay, either 2 or 5 is okay. This prime factor here is 3, so 3 will go for what? Recurring. So terminating, 5 will go for terminating. So this is 5 here, I'll go for terminating. And definitely this is terminating decimal fraction. So I need to use calculator to confirm this one now. So guys, this is difficult. Okay, so how do I confirm this? There are some calculator, if you press 0.375, it will help you to convert to fraction. So I don't know if you have that kind of calculator. That will be an advantage. And I'm going to try that now. But for some reason, my calculator is not doing that. So I need to give it a try. Now, the fact now is that this is terminating. Definitely it can't be this because this is recording. It can't be this. This will be recording because this is 3 here. So let me try 3 out of 8. Then I'll also try the remaining terminating kind of fraction. So 3 out of 8 gives what? 3 out of 8 is 0.375. Just the first trial, guys. I'm just fortunate. First trial gives me that. This is recording. So for this to recording, then is the prime factor, the denominating prime factor, the denominator, the prime factor, the denominator. This should be 3. So 3. So this will be correct. Guys, the prime factor here is also 3. So this could be recording too. So all 3, or anytime the prime factor of the denominator is 3, guys, is going to give you recording. Anytime the prime factor of the denominator is either 2 or 5, then it will be terminating. Okay, this one is recording. Okay, so let me try 2 out of 3 for this one. So 2 divided by 3, 2 divided by 3 is what? That is 0.666. So I'm just fortunate, guys. It works here. 0.6, this is terminating, so you should go for either of these two. I don't need to check these two because I know this is recording. This is terminating already, so I should check just these two. So let me check 3 out of 5 and 3 out of 4. So 3 out of 5 gives what? 0.6. First trial, guys. It's good to be smart. Then this is recording. So recording should go for either of these two. But this is 1/3. Definitely, I know this is correct here. This is terminating. I don't need to check because this is recording, and the remaining terminating is here, so I'll just put this one here. This is recording. Guys, I should get 100. Let me check. Yippee! I'm just too good, guys. Okay, guys, that's how good it is. Guys, it's good to have some good concept to be able to solve your problem when it has to come with numbers and system. So don't forget in numbers and system to have recording. Then the prime factor of the denominator should be 3. And if the prime factor of the denominator is either 2 or 5, then it will be terminating. Okay, next question. Okay, guys, do play basketball, guys. I'm just too good. Yeah, so guys, you guys, you go for B, then I'm A. So definitely, I'm going to purposely, I'm going to miss a question so that B lose, guy. I'm hey guy, just go for A. Why not A star, guys? Okay, so I want to take my throw now. So which type of decimal is 4 out of 5? Now I don't need to, guys. I have the rule already. Anytime the prime factor of the denominator is either 2 or 5, it is terminating. So since this is divisible by 5, then it is terminating. Whoop! Yippee! Next question. This is 11. My rule fails here, guys. Okay, because this one now, 11 is 2, 3 is this just a prime factor. I don't have rule for this, guys. I need to check. But guys, this is red turn. I will purposely miss this one, but it's just too early. I can't just take that risk. So I'm going to use calculator to confirm that. So 6 divided by 11. Guys, you can get rule for 11. I'm not sure. So this is 0.5454. So 54 keep recording. So it's recording, guys. VP, I'm cool. So next question. 1 out of 10. This is divisible by 2 and it's divisible by 5. Since it's divisible by both 2 and 5, then it is terminating. Yippee. Next question. This is divisible by 2, 3, and 5. What? Why are you so cruel? So because guys, this is divisible by 2 and 5, so that will fit in as terminating. It's also divisible by 3, and that will fit in as recording. So guys, this time around I need to work with calculator. But if I were to reduce this to lowest term, I'll be able to determine. Guys, don't forget, I'll be able to determine without using my calculator. But I'm lazy. So this is 3 out of 5. So it's divisible by 5. So 5 is terminating. Yippee. Next question. 13, guys. I'm going to use calculator for this one too. 3 out of 13 because I have no rule for that, guys. Okay, for some reason my calculator gives me something like not recording, not terminating, but I wouldn't say not recording. So because my calculator, the screen keeps displaying and end with 08, I wouldn't know. Probably my calculator round it up. So I will go for recording because it's not terminating. GP, I'm correct. So you have to use your discretion, guys. I use my discretion because my calculator, if my calculator screen display is longer, I believe it to keep displaying the decimal digits. So next question. This is divisible by 3 and 5. So since the denominator is divisible by 3 and 5, and 3 we go for recurring, 5 we go for terminating. So guys, I need to use calculator to complete this one too, because my rule will not work here too. 3 and 15. So 0.8666. So 6 is recurring. So it is recurring. Guys, I think I'm good with this. I think that's how we keep playing this game, and I have a lot of questions to solve. So you have access to the board work via my test shop. Guys, please just download and complete the task. So let's go ahead with the next. Hope you understand the concept already. So Jenny has a pizza that she's going to share with 8 friends. And if everyone get one pizza sized slice, how much of the pizza will they get? Guys, I have 8 friends altogether, so definitely each friend should get a 1 out of 8. So how would you express this as a recurring fraction, guys? This is not time for me to teach you how to convert fraction to recurring decimal. But let me just, I'm not going to teach you how to do that yet, because that was the last task we are going to do that. But I'm going to use calculator to complete this one now. So 1 divided by 8, and that gives 0.125. So the answer here is 0.125, and 0.125 is terminating decimal fraction. So this I can express it. Okay guys, I think I need to be fast because of our time. I have a lot of questions to complete, so I will not be careful to do this one. Guys, you have access to the board work, please, and just go ahead and download and complete, and the video too. So changing decimal to fraction now. So guys, this is where we are going. So it is important to remember that all fractions convert to either terminating or recurring. Guys, let me recall that again. It is very, very important to remember that all fractions convert to either terminating or recurring. Guys, I already taught you how to determine if a given decimal fraction convert to terminating and if convert to recurring. If the denominator is divisible by 3, it is recurring. If it is divisible by either 2 or 5, then it is terminating. So how can you tell if a fraction will convert to a terminating or recurring? Which of these fractions convert to terminating? Okay guys, based on the rule given before now, I'm not going to waste much time here. I think I'll be rounding up now for the next 10 or 15 minutes. So guys, you can go ahead and complete this one now. But I'm going to solve, I'll just give you the hint now. You have access to the board work. Now, if you want to look at the prime factor here now, you know when a number is divisible by 3, guys, let me quickly give you another concept. How do you know if a number is divisible by 3? If the digit sum of a given number, the digit sum, let me put it down here. If the digit sum is divisible by 3, then that number is divisible by 3. If the digit sum is divisible by 3, divisible by 3, sorry about that, I'm writing outside my screen. So if the digit sum, let me just put if here. If the digit sum is divisible by 3, then that number is divisible by 3. Else, it's not divisible by 3. Okay, so now how do you know if a number is divisible by either 2 or 5? How do you know if a given number is divisible by either 2 or 5? If the last digit for 2 or 5, you just go for the last digit. If the last digit of the given number is either 0 or 5, then that number is divisible by 2 or 5. So now look at the last digit here is 0. So definitely 2 and 5 will go in this number. And don't forget, I already told you that if 2 and 5 can divide a particular the denominator, then that number and what is going to be a terminating. So guys, I'm not going to write this one. I will just use arrow to indicate. So definitely this one here is what? Terminating. Okay, this is divisible by 2 and 5 too, because the last digit is 0. So this one here too is terminating. This number here is terminating. You just confirm with your calculator. The last digit here is 0. So it's divided by 2 and 5. Also, the digit sum is 3. So guys, this one now, the last digit is 0, is divided by 2 and 5. Also, the digit sum 1 plus 2 plus 0 is 3. So it's also divisible by 3. So in that case, I need to use calculator to confirm this one, because 2, 3 and 5 are prime factors in 120. So I'm going to use calculator to complete that one now. So 67 divided by 120. Guys, I wouldn't. Okay. So just use that. So this gives me 0.58333333. So 3333 means that it's recurring. So this is recurring. So yeah, this is divisible by 3. So it will also follow recurring. even though it's also divisible by 2. Okay, so because it follows this, it's okay. Since divisible by 2 and 3, then I need to confirm this one too, because 2 means that it's terminating and 3 means it's recurring. So let me just use my calculator to confirm that too. So 5 divided by 12, and that's also recurring. So I think recurring we have preference over terminating. So if it's divided by 3, I think we go for recurring. I need to make that, I need to do that research and be sure of that before I establish that fact. Okay, this one definitely is divided by 2 and 5, so this one here is terminating. I don't need to confirm. This is because 1 plus 4, it's not divisible by 3, it's 5, so definitely this is terminating. So that's the end of the game, guys. I'm true. Guys, this is video, you can pause, rewind, and go over it again. So factor with denominator only end prime factor, so I said this already. So place value now. Okay guys, this is the rule I'm going to work with now. This is board work, guys. I know you know how to do this one, so I'm not going to waste much time with this. So at this point now, because of our time, guys, you have access to this board work. This is a rule I'm going to work with now, but I'm not going to use this rule specifically because there are some questions that go beyond this. But let me just quickly work with this first. Converting recurring decimal to fraction is more difficult. How would you write 0.888 where 8 recurring as a fraction? So the first step is to equate the question to x. Then next, one digit is recurring because it's only 8 that is recurring here. So mean that you multiply by 10. If you have 2 recurring, let's say 828282, then you multiply by 100. If you have something like 825, then you multiply by 1000. That's what we are saying here. Then the next step, you have to subtract equation 2 from equation 1. So 10 take away 1x, that will give you 9x. Now because this is decimal and the decimal part required indefinitely, so this will cancel out. So you cancel out the recurring digit here. Then you have 8 take away 0, that is 8. So from here, 10x minus 1x, 9x. 8.888 minus 0.888, 888 cancel out. 8 minus 0 is 8. Then you divide through by 9. So if you put in your calculator 8 divided by 9, it will give you this answer here, guys. But the rule goes beyond this because of the kind of question we are going to solve next. So at this point, let me just run through this one without wasting much time. And here now, let me go back there. Okay, okay, so this one now, the recurring digit is we have 6363. That's why we have to multiply by 100 and go ahead with the same thing. So at this point now, I need to teach you a more applicable rule to that, because this rule may not necessarily be applicable in situation. So I want to use my board work now. Do you want to save the change? No, I don't want to save the change. Guys, let's take a look at the following questions. For some reason my stuff is I don't want you to waste my time, so let me just quickly pause and close that board work because I don't want pause. Okay guys, that's a cool one. I need to close that board work, it's taking time. Okay, so now the question now we have here, guys, don't forget you can actually access the board work via text. So just type this address, your URL, and access it. Then you can have access to a lot of videos also. Okay, then you can also write a program, an AI that will be able to solve this, guys. I'm trying to do that. You just write an artificial intelligence that can help you to determine if a given number is rational or irrational. Guys, that's up to you, guys. I'm working alongside. Okay, so question 1 now, which of these numbers are rational and which are irrational? That is the question. Now let me take my print screen now, guys. This is SlideShot. This app is known as SlideShot. You can download and it's very good. Okay guys, now the task I have before me here is to indicate some rational number with letter R, and irrational I will use I. So guys, I will just go ahead with rational, and so I will identify all the rational, and then automatically the remaining unidentified numbers will go with irrational. So now don't forget the rational numbers. Okay, all I need to quickly do this with you guys. We have set of natural numbers. Set of natural numbers are also, or let me just say counting numbers, are also set of counting numbers. So you have the element there, you have 1 2 3 4 5 6 7, something like that. Don't forget that this is also known as set of positive integers. So they are counting numbers. So rational number are positive integers, guys, they are the same. Then under this now, you have, above this, you now have another set of numbers. They are known as set of numbers, okay, of integers altogether. So set of integers are, can I just go with whole number first because of primary school students? Okay, so we also have set of whole number. So I will just use W there, and it's not necessarily W. Mathematical annotation for whole number is not necessarily W, but I just want to use this. Okay, because it's not we don't have notation for that. It give a particular notation. So W is set of whole number, and the first element here is 0. I say that 0 is not a member in counting number because 0 is not a counting number. So but 0 is a whole number. So 0, 1, 2, and it's an infinite set. So you can use 3 dots here. Infinite set 3 dots here. Okay, then so meaning that set of counting numbers, okay, is a subset of whole number. Then you have a bigger set now, integers altogether. So integers can be divided into positive and negative integers. So you have positive integers and negative integers, and we have 0 in between. So to the right hand side of 0 you have counting numbers, and to the left hand side of 0 you have the image of the counting number, which are negative part. Okay, so and they are infinite set too. Okay, then after this you now have your rational number, and that's what we are dealing with now. So this set of natural numbers, set of whole numbers, set of integers are all subsets of rational number. So meaning that everything here also fits in as a rational number. But I told you earlier on that rational number are what? Terminating decimal fraction. But if not terminating, then recurring decimal fraction. So you can define rational number in 2 ways. Terminating decimal fraction. If not terminating, if it is recurring, then it must be, if it's not terminating rather, then it should be recurring. If it's not terminating, then it should be recurring. Okay, so now let's go ahead now. So here now this will be red because this is a counting number. So all counting number automatically are rational numbers. This is decimal and it's terminating. I can express this as a fraction. Guys, this is a good one. Any decimal number that can be expressed as a fraction fits in as a rational number. I can express this one as a fraction too, so it's a rational number. This is a decimal number, okay, so it's okay. This is terminating decimal, this is a fraction. Okay, now the remaining element there are irrational numbers. So what are irrational numbers? Irrational numbers are set of numbers that cannot be expressed as a fraction. I think I like it like that. Numbers that cannot be expressed as a fraction, or better still, if you want to define it based on decimal, then that would be non-recurring non-terminating decimal fraction. Non-recurring non-terminating decimal fraction. So pi is non-recurring non-terminating. Guys, pi is not 22/7. It's just approximately 22/7. Pi is not 22/7. It's approximately 22/7, not 22/7. So we use this symbol for it's just approximately. Okay, so pi. Then anytime you have non-perfect square, you know what perfect squares are. 1 times 1 is 1, so 1 is a perfect square. 2 times 2 is 4, 4 is a perfect square. 3 times 3 is 9, 9 is a perfect square. 4 times 4 is 16 perfect square. Guys, you can generate infinite perfect square like that. So anytime you have any number other than perfect square, any number that is not a perfect square in square roots, what you end up, that type of number is what we call surds. So all surds are what? Are irrational. All surds are irrational. So something, if you put 2 here now, is irrational. Or square root of 3, better still, square root of non-perfect square are irrational. So this is square root of 5 is irrational. This is irrational. This is irrational. So let me use blue. I'm going to all irrational. I'll put all irrational in blue. So I'll put all the irrational in blue, guys. So let's just do that. So all irrational I'll put in blue. So so this irrational because it's non-perfect square is square root, non-perfect square is square root, non-perfect square is square root. They are all surd. Non-perfect square and square root are all surd. Guys, if you are given something like root 5 square, even though it's not perfect square, this square root will cancel out this square, so you end up with a counting number. So this will be a rational number. But because anytime you have irrational number raised to the power of odd power, then it will be irrational. But if it were to be raised to the power of even number, then it will be rational. Okay, so finally, this is also irrational. I have not confirmed this guy. So let me just go ahead and do that. So what is cos 60? So cos 60 is 0.5. So that should go for rational, because 0.5 is terminating. Okay, so this is rational. 0.5 is terminating. So guys, and that's that. So I'm through with this question now. So finally, let's go ahead with conversion of decimal to fraction. How to express it. So question 2, write as a fraction. So guys, don't forget my rule, and so I'm going to buttress more on it here now. So let me take print screen now. Question 1. Guys, I will not be careful to solve question 2 because it's the same thing. Oh, better still, let's try. Okay, so now question 1. The first step, step 1. I'm not going to write step 1. I'll just write 1 like this. Step 1. This means step 1 because of our time. So step 1, you equate the question to x. So let x. Does this mean? Let me just write like this. Let me write the step, guys, so I don't want to get you guys confused. Step 1, st1. Let me just put like that. So let x. No, I write like this guy. Seems to be tired, right? Okay. So let x equals to the equation. Now, because and now let me now give you the reason now. Some I need to give you more concept here. Now, step 1 is such that the requiring digit should be written like 3 times. Minimum of, don't let me say 3 times, at least 2 times. You should write the requiring digit at least 2 times. So then write this h1 at least 2 times. h1. Since I want the minimum of 2 times, so let me write it just 3 times. Okay. So when I say at least 2 times, then just go ahead. Let's say conventionally write requiring digit 3 times. So I can now put my oblot here. Because h1 dot dot means that h1 require indefinitely. So you can keep writing h1, 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 h1. So you let x equals to that. That's step 1. Then step 2, st2. Now the requiring digit here, we have 2 requiring digit. Then you multiply by 100. If this is digit that is requiring, then you multiply by 10. If you have 3 digits requiring, then you multiply by 1000. If you have 4 digits requiring, then you multiply by 10,000, because 10,000 has 40. So now since I have 2 digits requiring here, then I'm going to multiply by what? By 100. Okay. Then, but there is a rule that overrides that. The rule that overrides that, because of the next question we're going to solve, states that this decimal should be before the first requiring digit. Let me write it there. So this will override this one, because there's some question that multiples of tens. Yes, it's going to be multiple of tens, but not necessarily multiply by 100 in that form, because 5 could be here, and if I multiply by 100, then there will be trouble. Okay, so this rule override that. Is, I'm giving you a better concept now beyond what is inside the boardwork. I'm giving you a better concept beyond what is inside the boardwork. So now this rule now states that the decimal point, the decimal point should be what? Should be before the very first recording digit. The first, pardon me guys, let me write like that because of my time. Before the first recurring digit. Recurring. Guys, I'm not going to complete my recurring. I'm sorry about that, please. Recurring digits. Just pardon me, guys. Digits. So should be before the first recurring digit. So now the first recurring digit here is 8. So the decimal point is already before the first recurring digit, so it's okay. So I'm good with that. Then you can now go ahead with your, so the next one will now be 8. So meaning that this one is cool. That is this very question. Let x is okay. Then I need one more such that this one be before the first recurring digit. So the next first recurring digit is here now. So I can put the point here. Let me use blue now so that to indicate that. The next 8 is here. Then the next 8 is here. So that's how you can put your point. So if you are moving from here, that is multiple of 100. So that's why you are multiplying this one by 100 now. So if you multiply the left hand side by 100, that will be 100x. If you multiply the right hand side by 100, that will be 81. Then 0.81, 81, 81 like that. Since we have the two equations satisfy our rule that such that the dot, this decimal point is before the recurring digit, then you can go ahead and take away equation 1 from equation 2. So the red one is equation 1, this is equation 2. So that is down, take away up. So 100x take away 1x. That will give me what? 99x. So similarly, the decimal part will terminate. The decimal part will terminate here. So this decimal part will terminate here. You can cancel it out because we call it definitely. So you have 81 minus 0. So 81 minus 0, that is 81. And I want to get x, so I'm going to divide both sides by 99. And that will give me my answer. Guys, you can confirm that using your calculator. 81 over 99 should give you 0.81818181. But we can, the examiner can ask us to reduce to lowest term. So let me just do that, and that is 9 out of 11, 9 over 11. So guys, go ahead and put this in your calculator. 9 over 11 should give you 0.818181818181. So next question now. So this one here now, guys, you know the rule already. You have the rule, so I'm not going to waste much time. I will just discuss and then you guys just follow through. So let x equals to the question. So 0.512. Then the recurring digit here is 12. But this decimal part is not before the recurring digit, so this cannot be part of my equation because it does not satisfy the rule that says that this decimal part should be before the first recurring digit. So I want to change my the color now so that you understand better. Now this decimal should be here. So for it to be here, then how many place value here? Just 1. So then I can now take 10 now, so that will be 10x. Because to satisfy it, I have to multiply this by 10 for me to have 5 points. So that's multiplied by 10. So 10x will be equals to 5.12. Now I said earlier on too that we should write the recurring digit like 3 times. So I can write 1 2, then I can write 1 2 again. Can keep writing like that. So this one is okay. This is my equation 1. I need one more equation because I need to take away. So the next recurring digit is 1. So I can move this one here down here now. So let me change my color again. So let me use green now. So this point should be here now. So to move this decimal down here, that is 100 because 2 digits. So you are multiplying this one by 100. So when you multiply left hand side by 100, you multiply the right hand side by 100. So left hand side by 100, that is what? 1000. So 1000x equals to, so when you multiply this one too by 100, so that will be 512. 512, then point 12, 12, 12. So I have my two equations that satisfy the rules that says that the decimal should be before the first recurring digit. Then I can go ahead and take away equation 1 from equation 2. So go ahead with your calculator now. 1000 take away 10. 1000 minus 10. So that is 990. So this one here is 990x. So 990x equals to, don't forget that the decimal part will terminate. So sorry, we cancel out. So I can cancel out this one. This decimal from here is from here. So cancel out now. So I have 512 take away 5. So 512 take away 5, that is 507. Sorry about that. You can use your calculator to confirm that. So 507. Let me just confirm that so I don't prove to be too smart. So 512 minus 5, and that gives 507. So what do I do to both sides? I'll divide both sides by what? By 990 because I'm looking for x. So divide by 990, divide by 990. Okay. So meaning that x will now be 507 divided by 990. So guys, go ahead and plug that into your calculator and see. Let me see if I can reduce that to lowest term anyway. 507 take away 9, sorry, divided by 990. I say take away. So that is 169. Sorry guys, 169. So 169 now. Okay, so that is 169 divided by 330. So I just reduce it to lowest term. Okay, so to lowest term. So the answer is 169 divided by 330. Guys, you can confirm that, guys. Just in your calculator, just put that in your calculator, guys, and check. So when I put that calculator, I have 0.512, so 12 keep repeating indefinitely. So finally, let's solve this last question here. And the battle change hand here, guys. What do I mean the battle change hand? Guys, yes, because one more concept, guys, for you guys to learn. And after this, guys, go ahead and solve any, guys, you can solve any, guys, let me say it again. You should be able to solve any given question involving conversion of recurring decimal to fraction. So guys, this is the last concept now. I need to change my concept now. But this does not override the first one. It's just that because it's different condition. Okay, but this time around, the recurring digit here is 2. There's no umlaut here, so this is I don't. There's something wrong here, because if I have 3, 2, 4 recurring, I should have dot dot dot. So now the rule here now. So the rule here says that initially I told you that the recurring, your decimal should be before the first recurring digit. But if you have question like this such that there's some number in between, let me give you some other sample problem. Okay, so let's say that I have something like maybe 0, that's 0. It could be 70, it could be any kind of number. Let's say 70 point, maybe 5, 2, 6. My handwriting it's not too cool. Okay, 2, 3, maybe 5, 9. Just keep writing the digits as you like. Okay, now you now put umlaut here, 1, 2. Then you just jump 3, 5, 9. Then you now end your umlaut like this. So this type of question, so that you have some there's some spacing between. This rule is applicable now. So this rule says that this decimal point here should be behind the last recurring digits. Behind, okay, behind the last recurring digits. So, but if you have any other question, recurring digits, if the question is such that everything is there, they put umlaut here, umlaut here, umlaut here, then you have the first recurring digit. So that's what I'm going to complete this one with now. So now let's get started now. Now if you look at this dot here, is it behind the last recurring digit? Something like that. So I think I should be able to use let x first. Then I can make it complex, but I need not to do that. No, let me do that. Let x equals to, let me assume that maybe the recurring digit here is the last recurring digit here is 7. So mean that this one should come down here. So I'm going to treat it like that. So 0.453, 2, 4. The last recurring digit here is 4, and I have dot here too. So this dot should not be, yeah, it's behind 4 here. This is okay, but I'm not going to work such that it's okay, because you can also put it here and see okay. But I think I should just end the class. Okay, it's okay anyway, to be candid. I will not deceive myself. It's very, this equation 1 is okay because the last digit is 4 and this is 4. So let me just do that. So if you want to go beyond that, it's still okay too. So so that I don't waste much time. Now step 2 means that I need to now do this now. So but before I take this one, I need to follow my rule. The rule says that I should write this recurring digits as many times as possible. So let me just write 4, 5, 3, 2, 4. So I'm going to write it as many times as possible. I think I'm okay like this. So so let x equals to that. So now the last recurring digit here now, this is here. So let me change the color now in order to establish that fact. So this dot should jump from here and come behind the last recurring digit here. And how many digits do you have in between? 1, 2, 3, 4, 5. So that is times 1 with 5 zeros. So that is 100,000. So multiply this one now. 1, 2, 3, 4, 5. Because I have 5 digits in between the initial decimal point and the final decimal point, so that this dot come behind the last digit. 1, 2, 3, 4, 5. So x equals to, say, I can now take it now. So 4, 5, 3, 2, 4 dot, then 4, 5, 3, 2, 4. So since both equation 1 and equation 2 satisfy the rule, then I can go ahead and cancel out the decimal part. Originally this is where the decimal was, okay? So cancel out the decimal part now. Then work with the integer now. So 1, 2, 3, 4, 5. 100,000 minus 1. Wow, this is a serious question. 1, 2, 3, 4, 5. 100,000 minus 1. So that is 1, 2, 3, 4, 5. 5 nines. So 9, 9, 9, 9, 9, 9. Okay, so 5 nines. So I have 9. Let me just do that again. So that is 9, 9, 9, 9, 9. 1, 2, 3, 4, 5. X. So guys, use calculator to confirm that. Then finally, I'll just do 4, 3, 2, 4, 5, 3, 2, 4 minus 0. Wow, thank God for that. So minus 0, 0 is an additive identity, so it's not going to affect that number. So it will return the number back. So if you take 0 away from any number or add it, it's going to leave the identity the way it is. Okay, so now you divide both sides by what? By 9. That's nice. In 5 places. 1, 2, 3, 4, 5. Then I can cancel out this now. 1, 2, 3, 4, 5. So this cancel out now, guys. And game over. Guys, say that again. Game over. Game over. Scorpio wins. Okay, so just confirm that I want to put in a calculator, just confirm the answer. 4, 5, 3, 2, 4. 4, 5, 3, 2, 4 divided by 1, 2, 3, 4, 5. 5 nines. Okay, equals to. So in lowest term, the answer I have there, if you reduce that to lowest term, I have 5036. Let me just write that, guys. 5036 and divided by how many ones? 9 ones. 1, 2, 3, 4, 5. 5 ones. Better still, don't mind me. So SD. Woo! Correct. So that's the end of our tutorial, guys. Do well to subscribe to my channels, and can I see, do you have a great day ahead? Nope. So guys, don't forget, just type this address, your URL, and to access the board work, and also you can also access the complete video. And also please do well to subscribe to my channel and click like. Guys, do have a great day ahead, and bye guys. Love you guys. Solve more mathematics, guys. Bye.